Okay, good day, afternoon, or night. We are the team 5 from the robotic class, and we're going to present our webpage about the nervous system. And our teammates are Gian Alexander Andrade, Carlos Ramirez Melendez, and Nailiana Trujillo Galvar, and also me, Andres Caleo Garcia. We will start with the introduction.
The nervous system is a set of nerves and neurons that transmit signals throughout the body, acting as a type of organic electrical system. Many parts and processes of our bodies owe their function thanks to this system, which ensures that they are regulated correctly. The main function of the nervous system is to regulate important functions of the body, such as heart rate, breathing, and body movement. But for this project, we will focus on the central nervous system and the spinal cord itself. The central nervous system (CNS) consists of the brain and spinal cord. The brain processes the incoming information from peripheral tissues and generates commands, telling the tissues how to respond and function. The spinal cord has the ability to generate commands but for involuntary processes only. If you want more information, you can click this link that says Nervous System by Kenwood. And links to other sections, we have information of our robot prototype, uh, program, and UML.
Okay. Ab- About the information of our robot. We use it as the starting point, the problems that the nervous system can suffer and the solution. Um, Using this, we focus on the spinal cord. We plan that our prototype should be linked to the treatment of damage uh, on the spinal cord before exposed surgery, because there is a complicated process to start this type of surgeries. Our robots have functions to recover these injuries. As an example, it would be carefully programmed to be able to effectively remove any bone fragment or object that obstructs the recovery. And if we went to higher extremes, we could make it know how to take care or prevent any hernia or spinal inflammation. And talking about these surgeries, they are very ineffective because the nervous tissue of the spinal cord degrades and dies too quickly. And also too much time is wasted in preparing the individual spine for a correct emergency operation surgery. A robot will give more time to the doctors and specialists to carry out the surgery in efficient time, since it will be a difficult if not impossible for it, ideal for students like us. So we work with easier things at a range. And what is the robot doing? The robot follows a relative simple course with its purpose. It starts in an open cord surgery. A doctor leaves the robot at the bottom of the spinal cord. The robot walks towards the top, scanning for any irregularity or object that obstructs. And once the robot reaches the top, it injects anesthesia or any medicine and turns around, returning to the bottom and removing any obstacle that could interrupt the operation with a central report. Okay, now it's time to do the robot prototype.
So the robot has a structure similar of an insect, particularly a beetle, since the figure influences the movement. The robot does not use tires as it moves through the parts of the spinal cord that needs to be treated before an emergency spinal cord operation. The multiple flat legs allow it to walk without problems, while using its sensors to detect any debris or broken bones that hinders the operation, which it will remove using the central clamp on its body. We think that the position and size of the central clamp, as well as the main structure of the body, can cause problems when it comes to operation. We plan to modify the model to make it more realistic.
This is the first perspective of our robot. Let it charge. And this is like the second one, and it's from the top. We plan also to say that if it doesn't have wheels, it's because the wheels will mostly like obstruct the path in the spinal cord. Okay, now it's time for the program.
So first, the preparation of our robot. By the moment, like since we don't have a physical design of our robot, that is not like the 3D prototype, we can only like simulate how it will operate. So first of all, here is the algorithm, which is first to turn on the robot. This will do it automatically that it will insert the system. Then it will start movement. It has sensors, so it will move depending on the like the path. Then it will go to the spinal cord, and there it's going to start scanning with the sensors that it has. It will repair the damage of the zone, and the time will depend of the damage and what is treatment. So then it's going to clean the zone if there's like any rest of bone or anything. Then it will go back to where it started, and then it will turn off, and there is where that is when going to end. So here, like we have the next links of the flow chart and like the cyclic programmation. Um, there was the algorithm, and the next one is the cyclic programmation with on. So now we have the heroic programmation, which is a code, basically. And now we have the remote control, which is made by the blocks that had the remote control with an 8 block. And finally, we have the RC programmation. So here is what we do to make it like with the remote control, and that's all.
Lastly, the UNL is used to, if you are interested in seeing our institution. And that will be everything. And lastly, this is our prototype because we don't have it visible. And that's all. Thank you for your attention.